All right, so you've gotten pretty good at using find to pull documents out of your database. But what happens when you need to do more than just fetch data? What if you need to ask more complex questions? That's where we're going today. We're diving into MongoDB's aggregation framework. Think of it as the powerhouse tool that lets you perform really sophisticated analysis right inside the database, which is exactly where you want to do it.
And this is the big question, right? You're cruising along with find, it's working great, and then suddenly you need to do something more. You need to say, calculate totals for all your customers, or find the average rating for a product, or just group similar things together. A simple find just stops. It hits a wall. And that's exactly why the aggregation framework exists. It's the answer to this question.
Okay, here's a quick look at our roadmap. First, we'll talk about why simple queries just don't cut it sometimes. Then we'll get into the main idea, the pipeline, which is kind of like an assembly line for your data. We'll look at the key stations on that line, like filtering with $match and grouping with $group, and then we'll wrap up with how to add the final touches using $sort and $limit. Sound good? Let's jump in.
Right, so let's dig into this first part, the problem with simple queries. Why exactly do we even need something more powerful?
Okay, picture this totally realistic scenario. You've got an orders collection, and someone asks you to figure out the total amount of money each customer has spent. Now, you could use find to pull out every single order document. But then what? You've just got a mountain of raw data. The find command itself can't do the math. It can't group by customer and sum up the totals. That heavy lifting is now on your shoulders.
And your first instinct might be, hey, no problem, I'll just pull all that data into my application and crunch the numbers there. But, and this is a big but, that's a really bad idea. First, you're potentially pulling tons of data over the network, which is slow and expensive. Second, you're making your application do all this heavy computation, which bogs it down. And third, you're cluttering up your beautiful application code with a bunch of data crunching logic that really doesn't belong there. It's just inefficient. There has to be a better way.
And of course, there is a better way. This is where we introduce the hero of our story, the aggregation framework. It's all about processing the data right where it lives, inside the database.
So what is this thing, officially? Well, it's a native MongoDB feature that lets you process and transform your data in multiple steps or stages. But here's the absolute most important part, the key takeaway. All of this work, all this heavy lifting happens on the database server, not in your application, and that is a game changer for performance.
Okay, to really get this, the assembly line analogy is perfect. Just imagine it. You start with your raw materials. That's just all the documents in your collection. They get put on the conveyor belt. The first station does one thing to them. Maybe it filters out the bad ones. Then what's left moves to the next station, which does something else, like grouping them by color, and so on down the line. By the time it comes out the other end, you don't have raw materials anymore. You have a finished product. You have the exact transformed data you needed.
And this is so important. Just like on a real assembly line, the order of the stations is critical. You wouldn't paint the car parts before you weld them together, right? Same idea here. The sequence of your stages directly impacts not just the final result, but also how fast your query runs. Getting the order right is everything.
All right, let's look at our first and maybe most important station on the assembly line, the $match stage. I like to think of this as the gatekeeper or the bouncer at the front door. Its job is to decide who gets in and who doesn't.
Now, for anyone coming from a SQL background, this is going to feel super familiar. The $match stage in an aggregation pipeline is basically the same thing as the where clause in a SQL query. Its entire job is to look at each document and say, do you meet these conditions? Yes? Okay, you can go to the next stage. No? You're out. That's it.
So let's make this real. Imagine these 4 documents are our raw materials heading for the assembly line. We've got a couple of published articles, 1 draft, and a mix of view counts.
Okay, now we put our match stage, our gatekeeper, to work. The rule is simple. We only want articles that are published and have more than 1,000 views. That's the criteria for getting past the velvet rope.
And there you go. Instantly, 2 of our documents are gone. The draft article is out, and the published one with only 950 views is out. Only the 2 documents that met both conditions get to move on to the next stage. See how powerful that is? We've already cut the amount of work in half for the rest of the pipeline.
This brings us to what I call the golden rule of aggregation. If you only remember one thing about performance, make it this. Put your $match stage as early as possible. Always. Every document you filter out early is one less document that the more complex, slower stages have to process later on. On a small collection, it's nice. On a collection with millions of documents, it is everything. It's the difference between a query that flies and a query that dies.
Okay, so our relevant documents made it past the gatekeeper. Now they're on the main factory floor, and it's time for the real work to begin. This brings us to the dollar group stage, which is truly the heart of any analysis you're going to do.
So how does group actually do its magic? It uses these special operators called accumulators. You can think of them as the tools on this particular assembly line station. They're what let you perform calculations on the documents inside each group, things like summing up numbers, calculating an average, and so on.
And there are a handful of these that you'll use all the time. Dollar sum and dollar average for adding things up and finding the average are the most common. Dollar min and dollar max are great for finding the smallest or largest value in a group. And then you have cool ones like dollar push, which actually takes values from all the documents in a group and puts them into a new array.
Let's look at a concrete example. Imagine we started with a bunch of individual sales documents. After we run them through a dollar group stage, grouping them by product ID and using dollar sum, look what we get. We don't have a long list of sales anymore. We have one single document for each product with the totals already calculated for us. This is the magic of aggregation, transforming many documents into a few highly meaningful ones.
Okay, our product has been built and assembled. Now it's headed to the final stations on the line, the finishing department. This is where we polish the results and make sure they're presented just right. And the two main tools we have for this are dollar sort and dollar limit. It's pretty straightforward. Dollar sort does exactly what it sounds like. It orders your documents, just like order by in SQL. And dollar limit is also just what it sounds like. It cuts off the results after a certain number, like SQL's limit or top n.
So let's put it all together and solve a real business problem. The boss comes back and says, "Great, you calculated the totals. Now just show me my top 2 best-selling products by revenue."
Easy. We know exactly how our assembly line handles this. First, our data goes through the dollar group stage to get those totals. Then, the crucial next step. We send that summarized data to a dollar sort stage and tell it to order the products by total revenue, from highest to lowest. And for the final step, we pass that perfectly sorted list to a dollar limit stage and just say, "Hey, only give me the first 2." And boom, there's your answer.
And that really is the power of the aggregation framework. You take a complex question and break it down into a series of simple, logical steps. But the most important lesson here, the thing I want you to take with you, is to always think about efficiency. Always be thinking about that pipeline. So I'll leave you with this question to ponder for your own projects. Where in your data pipeline would filtering be the most effective? Get that right, and you're well on your way to mastering aggregations. Thanks for tuning in.